I still have my AC on at my house.
Oh, I do too, but this weekend it's supposed to be 75, so.
Well, we reached 100 this week,
Yeah.
so it's still pretty hot.
It's only in
Wow.
like these here.
We're getting up to the 52s. It's pretty great.
Our low doesn't even come
All right.
close to that.
I wish I was back in Hawaii and yeah. That's where I lived past year. So
Yeah, a little bit different climate.
yeah. Anyways. Alright, let's get started. Let's just open a quiz and go for it. Unless you guys have any other questions.
No.
This week's pretty simple.
I had issues with recoding, but we can talk that through if we have to go through that.
Oh jeez. So this quiz is 18 questions?
Yeah.
Joy.
The first two are really easy.
What? True and true?
Yes.
Yay. So 16 questions. Alright.
Soccer shoes.
In ANOVA hypothesis test, we reject HO when there is a sufficient evidence to indicate at least one mean is different from the others. I'll be right back. I'm going to look at my notes.
That's true, isn't it?
I think so. ANOVA test. We reject H when there's sufficient evidence. Yeah, no, that's right.
Yeah, it's true.
That's true. Number 3 is true.
Yeah.
Yeah.
Okay. What requirements needed to be checked when performing an ANOVA hypothesis? Mark all that apply. All sample means are positive. That is true. In each group are normally distributed. I don't know if that's true. Variances are equal to each group.
Yeah, it has to be normally distributed, whatever.
And
Yeah.
the variances have to equal. Yeah.
Yes.
All are true?
Yeah.
Yep.
Well, yeah.
Yeah, it says the pop has the same variances, right?
Yeah.
Yeah.
Be more than 4 times the smallest one or something. Okay.
Yeah. To check if each group is normally distributed, do the following. Construct a scatter plot of the data each group. Construct a histogram of all the data. Construct a QQ plot for each group.
QQ plot.
Mm-hmm.
Well, we just discussed this one.
Stop. My computer. All right. Sorry. All right. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample is less than the 2 times the smallest sample mean, or each group has the same sample size.
Number 2.
Yeah.
Is that a cricket?
I don't know what that is.
That sounds really weird. Anyways, an ANOVA hypothesis test is equivalent to conducting independent two-samples t-test between every pair of samples. If there are 3 samples, there are 3 pairs, 1 and 2, 1 and 3, 2 and 3. How many pairs are there when there are 4 samples?
4. What the heck?
Right.
Would there be 4?
There'd be
Or
more.
is there more? Let me get a pen. Un
Uh,
momento.
yeah. I hate this
It'd be 6. I think there'd be 6.
Yeah.
Oh.
And then 2, 3, 4. 1, 2, 3, 4. Yeah, I got 6.
Sure, we'll go 6.
Be right back. My son's yelling.
Okay,
Yeah, we got 6.
6.
Okay.
All right. The data in soccer shoes have collected to help determine how the design of soccer shoe affects the accuracy of a kick. There are 5 types of shoes, labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that has hung 115 centimeters up from the ground. Column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. What is the minimum smallest variance for the 6 groups? Let me just open SPSS here.
That one's where you have to do
What was that?
isn't that where you have to do like the different variances and the number and all that?
You were breaking up. I couldn't hear you.
Yeah, say that one more time.
It's when you have to do the plot, the graphs, right? Like the plots. You know, the histograph thing.
The QQ plot.
Yeah, that's what I mean.
I'm so much better at this in Excel than I am in anything else.
I never could get it to work in Excel right.
Yeah, could I?
Okay. So
Guys, do you want to know my response from the teacher about my test questions or whatever that I didn't get put through?
working right.
Yeah, she said, "I don't care. You should have. It's your problem. You should have figured it out beforehand."
How did you figure it out? Because wasn't there a problem with SPSS?
Yeah.
Well, I like how she's like, make sure SPS is working. So it's
Oh.
working, but I can't like pull up all the different things all the time.
Yeah, exactly.
I'm like, tell me what programs I need to pull up and I'll make sure those ones are working. But then I can look up the questions and figure the questions out.
Yeah, she said it was my fault. I hope she.
That's lame. She seems very unforgiving.
Oh. All right. So we need to.
Now, I can't figure out the variance for A. That makes sense? If I'm even doing it right. So I pulled up the descriptive stuff. And so it gives you the mean, the minimum, maximum, you know what I'm talking about, and it has your variances in there.
Mm-hmm.
Am I doing that right? I've never done this one before. I just. Oh, my goodness. So, what's the smallest one?
Mm-hmm.
Did you figure out how to do it?
I'm trying to. Hmm.
Geez, that one had a lot.
Yeah, so how do I transform the data?
Okay, so you go transform, recode, automatic recode. You have to
Okay.
do the footwear,
Okay.
you know, because it has A, B, C, D.
Wait,
Move it over, and then you have to change the name. You have to give it a new name.
Footwear. Foot. Add new name.
And then just change
Okay.
whatever, and then hit OK.
And then go to analyze.
Yeah.
And then compare means independent sample t-test.
No. I did explore.
Oh, one-way ANOVA.
Yeah, you do that.
Right.
And I went back and explored it so that way you get all the other stuff.
Explore.
Yeah, you have to do analyze, descriptive, statistics, and then explore. And so then you have to compare the dependent list, which is your kicking accuracy, to your factor list, which is footwear. Shoot, my battery's going dead.
wait, so do we go to analyze or do we do the
Do both.
explore part?
Do both.
Okay, so with our analyze, we go to our footwear, right?
Yes.
In our dependent list.
Hold on. Are you doing analyze and then compare means? That way? Or are you doing the descriptive statistics?
I just did the transform and now I'm in analyze.
Okay, go ahead and do compare means and then one way ANOVA.
Compare means one way and okay, yeah, I'm there. So now I do my new name, footwear code.
No, this is not where you do your new name at. So you do have to, I'm sorry, you have to go to analyze, descriptive statistics, and then explore. Oh crap, no, that's not right either. I don't know what I did. Just got there. No, oh, when you do your transform and then your automatic recode, that's when you do.
You're frozen. I can't hear you guys.
Hello? Hello?
Hey,
Hey, did you already rename it? Your footwear one?
yeah, I already renamed it.
Okay, so then you need to, yeah, go ahead and go to analyze, then compare means, and then one way ANOVA.
Okay.
And then your kicking goes in the dependent list, and your footwear goes in the factor. And that's going to give you your plot. The box.
That's easy.
But that's not all.
All right, now what do we do?
Okay, now, which if I don't know if I'm doing it right or not. No, let me look. Then you need to go to Analyze, Descriptive Statistics, Explore, in the same way that you've already done. But you gotta change the the plots. Make sure you add a histogram and normal plots with tests.
So my dependent goes into kicking accuracy,
Yes.
and my factor list goes into
Footwear.
footwear. And
And
my
then
label
label cases
cases go
by.
footwear code.
No, it's blank.
Okay.
So the one you renamed, the footwear that you renamed goes into your factor list.
Okay, wrong one.
Yeah.
And then what goes in our labeled cases?
Nothing.
Okay.
And then you need to plots.
Okay.
Click your histogram, normality plot, and then hit continue. And then okay.
Normality plots? Sorry. Oh, histogram. Sorry. And that's supposed to give me a histogram of each one?
Yeah, but also do you see that if you kind of scroll down just a little bit, it gives you the ANOVA plot box, and then you have your footwear. It has the case processing summary. Go down, it has your descriptives. And so you have A, B, C, D, E, and then your socks. So I looked at my variances in each one because I think we're trying to find like the lowest or the highest one. The smallest and the largest. We need to know the smallest and the largest.
Yeah.
I think that's how you do it.
Ugh.
But then you can look at your histograms too, and it tells you like the mean standard deviation of the number. Let me look at the homework. Because I don't remember anything on variances in the homework. Oh wait.
So the variance is the square of the standard deviation sample.
Okay, so I guess we would just pull it off that descriptive box for each.
And the square of that, each standard deviation.
Isn't it already calculated for us?
Oh, in Excel, it's already calculated for me.
What do you have for A?
For A, I have 27.358.
So it's actually C because that's 27.208. Did you get that?
Okay, 27.208 is what I got for ABC. Yeah.
So that one's the smallest. And then the largest one is the socks one because it's 40. You get how to do
Well, actually, 1, 2, 3, 4.
Oh, no, I'm sorry.
My fourth, the 53.
Yeah. Did you get how to do it, Taylor?
Yeah, I got it.
Oh.
I'm just waiting for you guys.
Oh, you should have said. Whatever. I had a hard time.
It's okay. So, and then 53.158. Is that what you guys got for the largest one?
Yes.
Okay.
See, I can do it in Excel and get the same answer.
I would just do whichever one you're more comfortable with.
I usually, for tests, I do it in both. And I check myself in both.
That's a good idea. My computer is being so slow for some reason.
A test for equal variances is satisfied for these data.
Mm-hmm.
You guys QQ plot them?
Oh, yeah, I did.
So we're looking at the QQ plots. Is that what we're doing?
Yeah, they look pretty. It looks pretty.
What has to be? What's the question again?
The test for equal variances is satisfied for these data. That's the requirement.
I would say false, right?
Oh, now this is where we need to check to see if the largest is 4 times bigger than the smallest.
Yeah.
It's not.
How do you do that? I forgot.
It's not. 27 times 4 is way more than 53.
The test for equal variances is satisfied for this data.
Oh, well, we could just put false and then if we get it wrong, we'll just change it back to true.
Yeah. Hey. Yeah.
So number 11 is true.
Number 11.
Mm-hmm.
What did you guys get for number 10? Did you get number 10 as false?
That's what you said.
Okay. Just checking.
I don't remember how to add it up to see if it's 4 times smaller or larger. I'm sure it's simple, but
I guess we'll find out. All right. Perform an ANOVA test in SPS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when you remove the SOX data?
I got 0.178.
That's when you remove the SOX?
Oh, I didn't remove the SOX.
because the p-value is supposed to be 0.081 right now.
I got that p-value.
I'm trying to find it because I did it a couple times and I was trying to find it. Okay, so now we just move.
So to take out
SOX.
the SOX data, is it just all or what?
Mm-hmm.
That what we're doing?
Yeah.
Manually go and delete it.
Yeah, I don't know how you just remove it. Surely there's. Just leave it out.
My p-value is not 0.08.
Oh, you're crazy.
On the quiz, it says perform the ANOVA test in SPSS and observe that the p-value is 0.081.
Okay.
Jesus.
So how do you remove just one of them?
I guess just delete it out completely and then you'll have to recode it.
Ew.
If you could, I don't have time to mess with it. Just delete it. Transfer.
Nice.
Mhm. Okay, well, what did you get for your p-value now?
So I just deleted the socks
Do
app.
it because
Forgot it has F instead of T, so I don't know.
I got 0.309. I don't think that's right.
That's what I got.
0.309?
Yes, that should be right because I did get the p-value of 0.081 last time.
Okay.
Let's see what Taylor gets.
okay. Okay. Analyze. Compare means. Sorry guys, my computer was being really slow for some reason for a minute. All right, let's see what I get. 0.309.
Yes.
Yay.
Okay.
So it's always positive, so it's always to the right. Right? No,
Cool.
all the time because then it can be to the left.
Yeah.
The test statistic. Oh, you're answering the next question. I see what you're doing.
No, but I don't know if that's right or not. I mean, I thought it, somewhere it said that it could also be to the left or to the right.
No,
Well, if
it
that's the
says
case-
F distribution is right skewed and it's never negative.
Okay.
F distribution is right skewed and never negative. That's what I
Okay.
got too on my notes.
Now I have it somewhere.
Silly Lisa.
Well, that's why I said wait, because I know I was probably not right.
All right. Let's examine the calories first. Construct a QQ plots of the calories for each of these three types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
So you just recode the type only.
I'm hungry.
Are we doing calories? What are we doing again?
Yeah. So when we put it in like the dependent list of the factor, are we putting in like the meat or the calories? And as the dependent.
Calories in. Oh wait, what's the question? Yeah. Hey, don't roll your eyes at me. Yeah, the calories.
Put the calories as dependent?
Yeah.
And the meat as the factor?
The type. Yeah.
Yeah. I just renamed it meat. All right, and then descriptive statistics, explore. Dependent is calories. Factor is wheat. I'm getting tired.
I don't know.
The assumptions have been met. It's safe to assume each group comes from a normally distributed population. We can also assume the variances are equal. The assumptions have not been met. While it is safe to assume each group comes from normally distributed, we cannot assume the variances are equal. The assumptions have not been met. It's safe to assume each group comes from a distributed population, but we can assume the variances are equal. I wish SPS could just tell you these things.
Yes.
SPS is the worst. Like, all I have to do is just delete in Excel. Highlight and delete. Copy and paste. Awesome.
We also have to look at the variances, not just the key.
Test of normality.
It should be interesting. Oh, thinking about this answer.
You guys, my QQ plots are all over the place.
I know that's kind of
Yeah.
mine too.
That's how mine are too.
So we can say that it's not met, but there's still 3 options.
Yeah.
But
So
it's not safe to assume that each group comes in from a normal distributed population. So that knocks it down to 2.
and we can assume
Bottom
the variance.
two.
The last one. We cannot assume the variances are not equal because they're not. Right?
But they're close.
They're close, but they're not equal.
But the variances don't have to equal, they just have to be within 4 times, right?
I wrote the variances have to be equal. What is that?
Okay, so just go with the,
If not, we can always change it, right?
I don't like that question.
All right. Run the ANOVA test to determine the mean number of calories. It's the same for all 3 types of hot dogs. You should find the degrees of freedom are 2 and 51. That F equals 16.074, and that p-value is 0.00 with level of significance equal to 0.05.
2
What
and
conclusion to draw?
what do you
I
say?
have 2 and 57.
I have like 20 and 17.
That's what I have. But maybe they mean... I don't know what they mean by that.
I have 2 and 51 for my degrees of freedom.
We did it wrong.
Okay, so you have it right, Heather. And so,
No, I don't have it right. I have 2 and 57.
oh, I thought you said 51. Okay, this is what I did wrong earlier or something and had to, wait, might be.
F isn't right either.
Mhm.
Neither is my p-value.
Neither is my p-value.
What the
What'd you
heck?
guys get for your p-value?
Hold on, let me scroll down. I might be looking at the wrong thing.
I think I'm looking at the wrong thing too.
Okay, I have 2 and 51. My F value is 16.074. My P is 0.0000.
Okay, where are you looking for that?
You have to do a one-way ANOVA.
That's what I did.
So it's under the box plot.
Got it. I got it.
Okay, so what's
We're
the
good.
question now?
That's what I got too. So, what conclusion can we draw?
Sufficient.
We need to reject the null so it's sufficient.
Yes. All three product types. This is where I always get things wrong. Like I know it's the 2 sufficient ones, but I don't know how to pick. But Heather's good at picking.
Reject the claim that all 3 hot dog types have the same mean number of calories. Claim that at least one of the hot dog types has a different mean number of calories.
So the last one?
I want to say it's the last one because
It is.
our hypothesis is all or nothing.
Yes.
Yeah, that's what I'm gonna say too. Now let's examine the sodium levels. Construct a QQ plots for the level of sodium for each of the 3 types of hot dogs. You should see that the QQ.
Where'd he go?
Yeah, Taylor. I don't know where he went. He was done.
Okay, cool.
Okay, walk me through this through SPS. I need to have a better attitude and I need to figure it out.
Okay, do you have them
I have them pulled up.
Okay. Oh, there's
No, I
two.
haven't recorded.
Okay, so go
Transform code.
and you're only going to recode the type.
Okay. And then I need to make a new name for that.
Yeah. Taylor, are you there?
Okay.
Yeah. Sorry. Are you guys still there? I
Yeah.
lost you guys for a minute.
And then I go to analyze.
Yep.
And I go to compare means one way NOVA.
Yes.
Mm-hmm.
And then my dependent list is going to be my,
Mm-hmm.
no, it's going to be my new name. The new,
No, that's your factor. Your new name's in your factor.
okay. So my dependent list is going to be sodium then.
Yes,
Mhm.
and your calories are taken out.
Okay.
Okay. The smallest variant. Oh, I see now.
And then to QQ plot it, I go to analyze again.
Descriptive statistics. Explore.
And then my dependent is going to be my
Sodium.
sodium.
Okay.
Mm-hmm.
My factor list is my type, my new name, right?
Yes.
Mm-hmm.
And then I go to plots.
Yeah.
Mm-hmm.
And then I go to descriptive and I do histogram.
And then you have to check that little box in the middle too, like normality one.
Oh.
Oh, we have to do that too.
Mine are all over the place too.
I feel like we're doing this all wrong or something.
Yeah. Now we have to do the same way. Okay, so our highest one is that one, and the smallest one is that one. You should see if it's here. Okay, so that should be.
Ah.
I think it's D.
Oh, that is bad. I think so too, because they're not normally distributed.
Yeah, they're
Yeah.
all over the place.
I just have a feeling if we're always picking D, are we doing it right?
Who knows?
All right, let's move on. Despite the possible problem with the QQ plot for poultry, we decided to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test? What is the p-value?
It's the sodium test, right?
Yeah,
Is it
I know now I got it.
is it 0.17?
0.179.
Oh, 179. I thought that was a G for 7 for some reason.
Is that what you got, Taylor?
Yep. Sorry, I had to scroll down all that far ways.
Okay.
I am praying for 100 right now.
You can take it again. Oh, so you don't have to redo it.
Yeah.
What's
What
8?
conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use level of significance of 0.05.
So we failed to reject it, so we have insufficient data. Right?
Yeah, but they all say
Yeah. No, there's number 2. It's
oh, we do not have sufficient
we
evidence.
do not have to
Tricky.
reject the claim. So it would be B. All
I
right,
think-
guys. Who wants to submit it?
I don't know. Okay.
I'll do it. I'll do it, guys.
I said I would do it. Taylor, you want me to do it or not?
Do it.
Okay.
Just do it.
Okay. Just thinking. Okay. Oh, we got one of them wrong on question 4.
Is that it?
I don't know. Let me keep looking. Nope, we got number 10 wrong. So it's false. Number 10's false. Oh, number 14's wrong. And 16's wrong. And those were the ones where like the 16 was where the assumptions have not been met. We put D. Yeah.
So 10 is
Well, true.
true?
I think it's because they were close.
Yeah, you're probably right. And then 4 was wrong?
It's not, it's just a part of it's wrong. So we picked all 3, so one of those is not right.
I'm going to
Maybe-
say...
Maybe the sample means aren't all positive.
Values are never negative.
It's got to be data in each group are normally distributed. Because they're not all normally distributed.
Take a shower.
Yeah, in a little bit. We're almost done, okay?
And then we need to read.
A little bit longer, okay?
When it's Christmas, it turns off.
When it's Christmas, it'll turn off. Okay.
Put the other one, okay?
Okay.
So,
You're thinking it.
And then 14 was wrong.
Yeah.
Let's see.
And I'll get a treat.
Okay. I'll come in there in just a minute, okay?
I
I'm going to say it's going to be C,
Which question are we debating?
14.
14.
I don't know. They're so close. While it is safe to assume each group You said C or what? B?
I said C.
I think it's C as well because it wasn't normally distributed. It
Yeah.
was all over the.
And then we got number 16 wrong. And that's it.
Yeah.
I'm going to go with C again. But
Wait. Oh,
wait 1 second.
Wasn't it C already?
No, it was D.
Oh, it was D. Okay. I switched mine. I think it was C as well.
Okay.
Why don't you guys try?
I'll try it. I'll try it. I'll try it. Don't go, Heather. I'm going to try it.
I won't do it.
I'm crossing my fingers.
All right. Let's see. Okay. We got number 14 wrong. So it's not C.
Number
Wait.
you
For
just
four. Oh. For
And
no,
I got
is it B? Is number 4 B?
I got 0.33 out of 1.
Oh. Well, you kept the sample mean right in there,
Yeah.
and variances are equal in each group in there, right?
Yeah.
And then you took out data.
Yeah.
So it doesn't say sample means are all positive. It says values of F.
Oh.
F is the variance among sample means divided by variance among individuals in the same sample. I don't know.
I'm going to have to go. Sample means are not positive.
And then we got number 16 right, but we got 14 wrong though, right?
Yeah, correct. And so it's not C.
We're D, so we're now to A or B.
Do you want me to submit mine with A or with B?
Yeah.
Is that a good guess?
Yeah. Do it.
Wait, but it has QQ plot A.
All right, submitting.
Okay.
$14 is not B.
What is A?
So it is A.
It's A.
What is number 4? Did you get 100?
No, so 4 I just put variances are equal, and that is part of the right answer.
So it's got to be data and variances.
Data and
So,
variance.
Okay.
Good job, guys.
So it should give us 100.
Oh, yeah.
14's A.
Yes, 14 is A. And then you said 16 is C, right, Heather?
Let me check.
Yeah, 16 is C. I got that on mine.
Oh
I
yeah.
only got 4 and 14 wrong on my try.
Let me resubmit it, and that way if we get it wrong for some reason, we can try again if we can get 100.
Okay.
Okay. So is 3 true?
Yes.
4 is data and variances. We're going to assume. What is 5? The QQ.
5 is construct the
C.
QQ plot.
6 is the largest. Okay. And then 7 is 6. 8 is 37.208. And then 53.158.
Hey Heather, what is 5?
5 is it's C. Construct a QQ plot.
Yeah. Number 11, is that true?
11 is true.
Okay, what is number 12?
0.309.
13 is right.
Correct.
14 is A.
A.
Oh my god. 15 is
D.
and then 16 is C. Right?
Yeah.
And 17, the p-value,
0.179.
0.179.
Yeah.
And then the last one, is it D? 18?
B.
No, it's B.
Okay. Okay, so on question 4, it's the data and the variances.
Yeah.
Yeah. Anything else is good? I will say I went to the review for a little bit, but I think we're doing a lot better than some of the other groups.
Really?
Yeah.
Okay. Cool. All right, well, I got 100, so I'll peace out.
See ya. Bye. Oh, wait, I have a question.
See ya.
Taylor, wait.
Well, what's up? What's up?
Do you guys have time to meet tomorrow to do the review, or do you want to just keep it as Thursday?
I have all the time in the world tomorrow.
I have time. I just have mutual from 7 to 8 Arizona time. So if we want to do it before,
Or after?
yeah, but we can do it
It doesn't
before.
matter to me.
So that's like 6 my time, but 7, 8